Greeting Earthlings! If you follow the channel, you know that we love all things Apollo, and that during our last visit to Steve Jurvetson's amazing space collection, we were given the opportunity to take 2 holy boxes of Apollo electronics to our lab. These are the boxes that brought you voice, data and live TV from the moon. The Apollo S-band radio system is really 3 links in one. The up and down phase modulated or PM links, which transmit live voice, data and ranging information, and the FM downlink, which transmits recorded voice and data, scientific data, and last but not least, live television. It took us many episodes to get the PM links going, and we are now working on putting data and voice over it. But this involves the super complicated pre-modulation processor, or PMP, which we labored over in the previous 3 episodes. So complicated, in fact, that we eventually realized that we needed to reproduce a part of the astronaut's command panel to control it. It's being manufactured by our sponsor PCBWay as we speak, and while we were waiting for it, we had a brilliant idea. There is one transmission that does not use the PMP, the television signal. So while we wait for our control panel PCB to arrive, why don't we try to transmit some TV from the moon? I mean, from the other end of my big table, but on the same radio equipment used by the Apollo astronauts. We already know our spaceship FM transmitter is working. We got it going way back in episode 5. How much fun can you have with $1 million of equipment? So all we need to do is to restore the NASA FM ground receiver, a period correct Vidicon camera, and a period correct black and white monitor, and we should be in business. But although we have all that hardware lined up already, there is just one small wrinkle. None of it works at the moment. So let's get cranking. So next, PM receiver?
FM receiver.
FM receiver, yep.
Yep.
I haven't plugged in yet. Plugged it in yet. It looks like the PM, but the interior is very different.
Yeah, it's like designed by completely different people or something.
We still have the attenuator at the front, but then the mixers over here, the local oscillator is kind of one unit. Much simpler. It's not PLL'd. It's not phase locked. It's auto tuning though. It says manual tuning or automatic frequency control. So it's just like more like a normal FM receiver, but with much wider FM modulation. Let's give it a try, see if it comes to life at least, and we can receive anything.
Alright.
Blonk.
Does this one have a power button on the front?
It does. Power. You want to... Okay, let me see if it's on or off. Off. Okay. Oh! And it was on. Oh, and the lights all work. Okay, tuning.
At least half of all the lights work.
Yes. Yeah, 1 out of 2.
Okay.
So you have 1 light to change. Oh wow,
Just
this
one. Not bad.
Who knows? Ooh, this is stuck a little bit. There you go. Alright, 1 bulb.
1 bulb.
Piece of cake.
Interesting. So that side won't turn on at all. But this side,
Video output high or low.
that side, if I put it in there, turns on.
Oh, that works.
Okay, now it works. Perfect. Okay.
Okay, alright, we have all our lights. Okay, so we're trying a quick experiment. Transponder is hooked up through 10 dB attenuation, so I take the FM output, 10 dB attenuation, 20 dB coupler, another 10 dB, so that should get us down to, starts at 100 milliwatts, should be minus 20 dBm, which now we know is kind of a test sensitivity of these guys. And let's see if it wiggles, I guess, right? And if it doesn't, then we go do it with the HP instrumentation. And give us FM.
Okay, so draw power.
FM 400.
And FM enable.
Woohoo! This guy's doing something. That's a weird noise. From this guy?
There's the...
Oh, okay. Yeah, I see. Oh, is the counter. I see absolutely nothing here. Oh, AFC, let's try. Get this out. No. Signal level 0. We got nothing. Calibrate on. Ah, there we go. Okay, now we have signal level. So this thing has to be off. Okay, so we have some signal. It's seeing it. We're on the right band. And it's tuned. There we go. Right. It can receive it. It's at the right frequency. Okay, this one we hoped it would be at the same frequency because no, FM receiving unPLL, that's just only Apollo, nothing else did it. So they didn't change it. There we go, auto tune. Yeah, now it doesn't move anymore. It got it.
Sweet.
Woohoo! This must have been the easiest bring up by a mile. Unlike our PM receivers, the FM1 had not been modified from its Apollo days and still works perfectly. Kudos, Motorola. So next up, let's bring up our antique video camera. And that's where things get a bit complicated and we have to summon the dreaded elevator music. The original black and white camera used by the astronauts was quite special. It did not use the normal NTSC 525 lines nor the regular 30 frames per second, because the resulting video signal would have used too much bandwidth. Instead, they designed a special slow scan camera with only 320 lines and 10 frames per second. This reduced the video bandwidth to just 500 kHz. This was needed because of a technical limitation only present in the LEM S-band system. In the LEM, to save weight on the S-band power amplifier, it was not possible to have both the PM link and the FM link transmitting at the same time. So in order not to lose the live voice and data transmission subcarriers that were on the PM link, they transferred the subcarriers from the PM to the FM link before switching the TV on. It was now possible to switch off the PM and still talk to the astronauts via FM. The TV signal then had to fit in the space left in the middle. Note that no such constraint did exist in the command module because the heavier traveling wave power amplifier had two tubes and could support both PM and FM transmissions at the same time. Therefore, all of the FM bandwidth was available to video in the command module. Bear that in mind because this will have important consequences for color TV, as we will see later. But for now, let's stick to the original LEM black and white camera used on the moon's surface. There was still one more important way the camera was different from a standard one, namely the scheme used for syncing. In analog TV, you need to add pulses to the video signal to indicate the beginning of a horizontal line and a vertical frame, so that the television monitor scans at the same rate as the camera. These are the negative pulses seen here, which go below the black level. But in the Apollo camera, the sync pulses were totally different, being short bursts of 500 kHz, which is very unusual. This document explains that this was done to improve dynamic range, as no extra range below black is consumed by the sync pulse. You can spot the signature of the unusual 500 kHz sync bursts on our drawing. It's on either side of the main video signal. And of course, since the camera signal was special, the TV monitor on the ground had to be a special slow scan model too. And then you could not broadcast it, not even to Houston. So an enormous machine called a scan converter was used to convert the slow scan picture to the NTSC standard, suitable for broadcasting to Houston and the whole world. This is a picture of the scan converter at Honeysuckle. Here is another one. The converter is behind legendary news anchor Walter Cronkite. The conversion was done in analog fashion, simply by filming the slow scan TV monitor fitted with extra slow phosphors with a regular camera. You can imagine that the picture quality was severely degraded in the process. There is no surviving slow scan footage, as the tapes were famously overwritten by NASA itself around 1980. But a few pictures taken off the Honeysuckle slow scan monitor survived. You can see how much better the original slow scan images were. Here is a slow scan picture of Armstrong and Aldrin, and here's the scan converted version of the picture. Dramatic difference. And here is a slow scan picture from Apollo 7 from Earth orbit, so the quality is even better. Note that there were different cameras used. The black and white lunar surface one was made by Westinghouse, which was mounted upside down when filming the astronauts coming down the ladder, then later on put on a tripod. Most of the inside cameras were made by RCA. The early ones are black and white and later they become color. More on this later. But alas, we were not able to get our sticky hands on any of these. So instead we are going to brute force it and transmit regular NTSC over the link and see if we can get away with it. I think we should be okay since we are using the whole FM downlink for TV only and have its whole bandwidth at our disposal. Fingers crossed. So on the bench we have a oldie camera that we maybe give us a signal for doing TV transmissions from the moon, and turn it on, smell bad, and with the just looking where the smell was coming from, we found that bad resistor. Otherwise it's pretty, but there doesn't seem to be much schematics to it. Here's a beautiful tube, power supply on the other side, says 4.7 kilo ohms, so maybe it's still half alive. We have to find out what makes it smoke. I hooked myself to the cap is shooting into. It's 0.5 ohms. It could be that, or it could be one of the tantalums across the board.
Tantalums usually let out much more smoke when they go short, though, don't they?
Yeah, but if there's a resistance in front of it, then the resistor took the brunt of it. I don't know. But we can just snip that capacitor and find out if it gets better. Our cap is okay. So we'll pull out the resistor, then see we have, yeah, so short somewhere else. Okay, it looks like we've found a bad tantalum. So this turned out to be a power rail, so go for it. So it's the plus power rail, snakes everywhere, and then we tried to find if it was connected to a tantalum somewhere. And it sure did.
Yeah, that's
0.5 ohm. Okay. Alright. So this is only a 4.7 ohm, we think, because under the microscope the last band is golden. Shoots into a capacitor, so that was a decoupling for the input power. Remove the tantalum. Can you check that my my short has disappeared from here to here
to this rail right here.
Yeah, it just disappeared, so it was a tantalum. Okay, so put back a 4.7 ohm resistor, a better tantalum, or a non-tantalum. Okay, we replace our 2 tantalums with electrolytics. There's a few more tantalums that we should probably replace, but I don't have them quite yet. And put a new resistor and see if it still smokes. Ready for it, Eric?
No.
Okay, on. Nothing seems to be.
15 kilohertz.
You can hear
I
it?
think.
That would be good. I can't hear it because I'm too old. Ah, no, I could hear it. I heard it too. Okay, well, let's see if we get some output from this thing. What do you want to flip the switch?
Alright.
Haha!
Oh.
Video! Yeah,
Yeah.
video.
Getting video.
Okay,
Lines.
yeah, there we go.
Getting sync.
So the only thing we don't have an objective for this camera.
Right.
What? This thing has a weird... I was wondering if this was a scientific mount. This was on the microscope of some kind, or something scientific, because that's not the usual mount at all, this thing. But the next step is the monitor. So, next up is this guy, which has the great 60s appeal here. You can already see something has happened with it. So this is why I never do these. This is consumer electronics. Yeah. Oh, the nut's just fallen off. That's all there is. Complicated. With wires flying all over the place. Definitely. Okay, I'll just put the nut back together. It's over here, floating around.
Moments later.
Is it gonna explode? No. Ooh.
We have a raster.
Okay. It's going to take a while.
Oh, we have to wait for it to warm up?
Yeah.
I always forget about that. Oh, there we go. Oh.
Yeah, we see something. Okay, so we just don't have an objective on that thing. Okay, so let me try to find some length somewhere. Okay, we removed the objective, which I think was a projection system for a microscope. Oh. Can't focus on anything. So here approximately 1.6 inches. Do I reach into? Yeah. So it's in front of the tube here. It does work.
All right.
All right, we have picture. Yeah, I did a quick combo of simple machining and super gluing things together. Come on, Eric. Yes. There you go. Well, that's a good picture. Go back so I can focus. There we go. And then I have...
It's picking up a lot of infrared, looks like.
I think we have a system to take pictures from the moon. There you go. With the right vibe, the right 1960s vibe.
Yeah.
Alright. Alright, so our setup is getting bigger. We have the uplinked command box, the transmitter, the FM and the PM receiver, still some HP test equipment, the transmission side, the camera for the TV, and under the earth here we have the monitor. And the idea is that we try TV from the moon. or from that side of the table, which somehow still holds up, which is sort of a miracle.
FM on?
Yeah, do FM on, and we can see where we see it. I see no FM over here. Am I receiving anything here? I did forget something somewhere. Oh, I know why. No drawer path.
Ah. Yes, that will definitely do it.
Okay, try again. Ah, there we go.
And we've got a signal level.
And okay, we receive it.
And we've got a signal on the oscilloscope.
It's tuning. It's auto tuning. Okay. So we're doing good. Here, where are we? Hello. So okay. So we have 2.718, and what should it be?
2272.5.
270. Okay. So we're doing good. And we receive nothing over there. So I guess we turn on the camera. So on the setup here, camera side, I am coupled to one FM TV in, goes to the camera. Then here we have to turn it to TV. Ooh, that I didn't like. Why? If we turn it to TV. Oh. What the heck? And oh no, it moved it somewhere. Let me go in a larger span. Okay. And 20 megahertz. Redo the TV wideband. Yeah, it just shifts it. That's strange. I didn't know that. It's a noise or a receiver. It's switched sideways. Okay, but it auto frequency compensated. Okay? So we're on TV. Is the camera on?
Not yet. Ready?
Yeah. Yeah. Oh! I have it. We got video. We're transmitting video. Is it too high? No, we were transmitting video from the moon. We are. No kidding. Okay, how many volts do we have? Yeah, a few volts. So it's low is okay. And wait a second. I have to hold on. I have to get out of 50. There you go. There you have it. Oh! Well, that was easy. TV from the moon.
So this is going through the transponder?
Absolutely. Can you move a little bit in front of the somebody? Yes.
Oh, that looks like
get a little lower. There.
There he is. Yep.
Wow. Try it again. Yeah. So I know why the shift is because we are not using the same format as they were. They were DC balanced, and they didn't use the black level for the sync. And we are using just regular NTSC with normal sync, so it's DC offset, so it will move it. That's totally normal.
Gotcha.
Go for it. Off. Yeah, picture goes. Neil, can you turn the TV on, please? Oh! Thank you, Neil. I think we can see some part of your control panel. that's this one over here, I think. Shooting on. That's good way of doing the control panel.
So if we use ranging at the same time, I wonder if we see any interference.
The ranging is on PM, so it won't do anything. You can turn ranging on.
Should I turn one of the PM?
PM is shooting into a low. That should be okay. Yeah.
So there's PM, and then ranging.
Yeah, there's nothing. Wow, I'm surprised. This is just regular NTSC TV, not even slow scan. And that is fantastic.
Wow.
So all we need to do is give a phone call to Madame Savage so we can do a fake moon landing. Well, that's pretty good. I'm stoked. Say something that somebody can remember. A small step for CuriousMarc, but
One giant leap for YouTube.
One giant leap for microwave communications. Alright. That's it, I guess.
Oh, wait, we should look back at Earth. Earthrise. Live,
So here we go, we have Earthrise.
live from the moon.
Right here, it's live from the moon, except it's your t-shirt. We're the official NASA studios.
That's right.
We don't really need to go back to the moon now. We have very good deep fake videos, so why go there?
Maybe this is how they faked the moon landing. They just put it on a t-shirt.
Yeah.
Alright, wow, that's pretty good. And while I was not looking, some strange things started to happen in my fake moon landing studio that I can't even explain. Well, we did not get to the color part in this episode, so we'll leave that for the next one. See you then!